Okay, now we're going to talk about natural logs. Natural logs just means they have a base at e. And if you look on your calculator, you can see ln is right below log, and you can go second e, put 1 in for the exponent, and that's what e stands for, 2.718281828. It's kind of like pi. We know what pi is. E is also one of those numbers, okay? And so it's used enough that it's programmed into the calculator. All right, so an exponential function with base e, well, let me get my draw up here, is going to be a natural log. That's what it's going to be called. Okay, a logarithm with base e is going to be ln of x or log base e. So you can see that this and this are the same. So most of the time we're just going to do ln of e or ln of x. Okay, so you could use your calculator just like I showed you and put e and put the exponent as 0.5, and that's going to give you 1.6487. And then you could do e to the negative 8. Again, this is just calculator work. And this would be 0.0003. Just make sure I got enough. Again, calculator work on this. You push the ln button and you put in 3. And so that's approximately 1.0986. And then if you want to do this one, it's ln 1 divided by 4, and then enter, and then you'll get approximately negative 1.3863. Okay? Now let's get into the more complicated stuff. And this is going to be key that you keep this in mind, that the natural log of x is the same as log base e of x. Okay? So I'm going to take this first one, and I'm going to take the log of both sides. Okay, so that I'm going to change forms here. What am I thinking? I'm going to change forms. So if I'm changing forms, this is where we have to be careful. That makes log base of e, these two switch sides. This is 23 equals x. Well, log base e, we can easily use our calculator for. That's just ln of 23 equals x. So in this case, x equals, I forgot to do this one, so I'm doing it, approximately 3.1355. Okay? On the next one, I can do the same thing where I can change forms. So the first thing I'm going to do is change this to the log base e of x, because remember, this means the same thing. And that's approximately 1.2528. Now I'm going to change forms. Our base is e. These two switch. So our exponent is 1.2528, and we can put that in our calculator to figure out x. So I'm going to go second ln, and I'm going to put my exponent as 1.2528 and equals, and that's approximately, so x is 3.5002. I round it. Okay? What you have to remember, that e of x is the inverse of ln of x, so they undo each other. So this should say inverses here. So if you have e and in the exponent you have ln, then they kind of cancel out and you're just left with an x. If you take an ln of e, whatever the exponent is the answer. Okay, so for example, number 4, if we're taking e of ln, these cancel out, so my answer is 21. ln of e, that cancels out because they're opposite, so that's x squared minus 1. So you have to remember that, or at least remember to look at that when you're taking the test. Okay, let's do number 5, 6, and 7. Okay, the first thing we want to do is get e by itself, because then we could change forms. Okay, so I'm going to subtract 4 from both sides. And then I'm going to see what I can do. 3e to the negative 2x equals 6. I want to get that 3 off of there. So I'm going to divide by 3. E of negative 2x equals 2. Now if I take the ln of each side, watch what happens. If I take the ln of this side and the ln of this side, these are going to cancel out, and you're just going to have negative 2x equals ln of 2. Well, ln of 2 can be put in your calculator. So then I divide both sides by negative 2, and that's just a calculator problem. ln of 2, enter, divided by negative 2 is going to give you negative 0.3466. Okay? So you can use the fact that E and ln are opposites to solve equations. So for example, we have ln of 3x, whoops, we don't need to write it again, it's already written there, equals 0.5. So let's make them both, let's put them all both as a power of E. That's a legal move because we're doing the same thing to both sides. We're just making E the base on both sides. What that does then is cancel this out because they're just opposites of each other, inverses, sorry. So 3x equals e to the 0.5. Now we have a calculator problem. Divide by 3, divide by 3. So you put e to the power of 0.5, enter, divide by 3, and you get x equals 0.5496. I love this stuff. It's so cool. Okay, let's do this one. I'm going to erase this part just so we can see this and that's not in the way. You can always go back. So again, I want to get rid of that e. So let's take the ln of each side and see what that does. Just make sure you do the same thing on both sides. Well, ln of e inverses, so now we're just left with negative 2x is less than or equal to the natural log of 7. Divide both sides by negative 2. Be careful. If you divide both sides by negative 2, we have to flip the sign. So that's going to be greater than. And now it's a calculator problem. Natural log of 7 divided by negative 2. I just get out my calculator. And that's going to be x is greater than or equal to negative 0.9730. All right, see what you can do with this. Again, I want to see work on the homework. I gave you the answer key. Now, numbers 1 through 7, there's really not, well, no, numbers 1 through 4, there's no work to show. But there is work to be shown on the rest of the problem. So make sure you show it for full credit.